million pounds of it, gushing from rocket nozzles that rise, slowly at first, from a launch complex at the Cape. It is the power of America. Knowledge, skill, energy, and imagination from every corner of this nation pool for this thrust into space. In July of 1950, American rocket pioneers at Cape Canaveral launched Bumper, a captured German V-2 with an Army-developed second stage. More than 1,400 missile and space vehicles have since roared skyward from the Cape. Some have probed deep into the secrets of the solar system, past the moon, past Venus, around the sun. On this proving ground today, foundations of national goals in space stand in concrete and steel. The challenge in space is infinite, but our nation's goals are immediate and critical. America's leadership on Earth demands leadership in space. The job is not easy. Witness this launch of a Titan II. In the test arena, engineers subject all systems to the most exacting laboratory conditions. The missile is destroyed. All tests, including this disappointing failure, contribute vital knowledge for the greater reliability of this weapon. Now, the Martin-built Air Force Titan II is the big stick of American leadership. Its 6,000-pound warhead can be hurled one-third of the way around the globe with pinpoint accuracy. This flight was a milestone. Long-range cameras record staging. The same phenomena is shown from space by cameras mounted on the second stage. Shown 33 times slower than it actually happens, the booster is blasted away at second stage ignition. This is the view that the Gemini pilots will have as they rocket into orbit. Seemingly motionless, the second stage is fast approaching speeds beyond 15,000 miles an hour. Station after station down the Atlantic missile range tracks the missile's flight and records telemetry data on its performance. Where there are no islands, range instrumentation ships like the H.H. Arnold fill the gap. Target zone is near Ascension Island, more than 5,000 miles from the Cape. 30 minutes after launch, the huge nose cone is there. Here is a sight few men have seen. A re-entry vehicle making its fiery plunge from space back through the atmosphere. Designed to withstand the superheating caused by air friction, Titan's nose cone survives to land squarely on target. As the flight ends, the job of compiling the test reports begin. Speed is vital. Some data cassettes are picked up on the fly by range aircraft, making information available to engineers in hours instead of days. The new parameters of missile and space operations are measured in microseconds and millimeters instead of minutes and miles. Back at Patrick Air Force Base, headquarters for the Atlantic Missile Range, flight information is already being checked. It shows this Titan's performance to be nearly perfect. This is good news to more than weapon system people, for Titan is earmarked to boost the two-man Gemini spacecraft into orbit. To Lieutenant Colonel John G. Albert on Gemini Pad 19, this flight had special significance. Colonel Albert is chief of the Gemini Launch Division, 6555th Aerospace Test Wing. Now, certain booster modifications to man-rate the Titan have proven flight-worthy. Colonel Albert checks the Titan, which will boost the first unmanned Gemini capsule into space early in 1964. From the blockhouse, he will direct all launches in the National Aeronautics and Space Administration Gemini program. Still, another version of the Titan II will be the core of the giant Titan III space booster. With big, solid fuel rockets strapped on either side of the liquid fuel core, Titan III will generate more than 1 million pounds of thrust at liftoff. Titan III will put enormous payloads into orbit. Launch facilities for this fast-reacting giant booster are under construction. Atlas, like Titan, plays a variety of roles. Atlas, built by General Dynamics, was the first operational intercontinental ballistic missile on duty with SAC. For NASA, it powered the Ranger moon probes, the Mariner flight to Venus, and the orbital flights of Project Mercury. Air Force crewmen need all their technical competence to prepare this complex system for flight. This Atlas, being prepared for launch by airmen of the 6555th Aerospace Test Wing, seeks both military competence and scientific truth. Passenger pods attached to the side of the Atlas carry a variety of experiments for basic research in the space environment. On the tip of this 90-foot tower of steel is a completely new type of nose cone designed to increase the effectiveness of this system.
2, 1, 0, 1, 2, 3, 4, 5, 6, 8, 9, 10.
300,000 parts functioned perfectly when the Atlas roared to life, living up to its reputation for dependability. Atlas and Titan are formidable weapons, but an indestructible intercontinental missile with a quick reaction time was needed. Minuteman, the solid fuel, instant ICBM that is fired from concrete underground silos, was the answer. By mid-year, Boeing was delivering Minutemen to SAC squadrons at the rate of 1 a day. And at the Cape, missile men were already at work on an advanced version of America's Sunday Punch. This early flight ended with an explosion that was visible for miles. Yet, even from such a brief flight, great quantities of information are gathered from telemetry sources. Resulting changes and improvements will soon have the advanced Minuteman as reliable as the earlier models now operational with the Strategic Air Command. This November test, employing an entirely new second stage, streaked more than 5,000 miles down the Atlantic missile range to score a strike. The Navy's new extended-range Polaris also experienced some difficulties in achieving its full 2,500-mile range. By October, design changes had so improved reliability of the new bird that it was considered ready for the acid test, launch from a submarine. Every missile-firing submarine comes to the Cape for a shakedown cruise, which includes the launch of a production model Polaris. The USS Andrew Jackson was chosen to fire the first new model Polaris. Loaded with the Lockheed Corporation's new Polaris, the Andrew Jackson cruised a few miles off the coast of Cape Canaveral and submerged. Then, in a froth of bubbles, the bullet-shaped missile surfaced, ignited, and sped away downrange. The Army completed development testing of their selective range Pershing with a demonstration of how this new tactical weapon earned the nickname Shoot and Scoot. Men from the Army's 2nd Missile Battalion of the 44th Artillery conducted this test under simulated operational conditions. The mobile launcher and support equipment, mounted on half-tracks, first made a grueling trek through rough Canaveral scrubland. Upon reaching the firing site, the rugged combat soldiers demonstrated their newly acquired technical skills by assembling the Pershing. Moving through the simplified countdown, the crew erected and checked out this new addition to the Army arsenal. The sharpshooting missileers hit the bullseye, proving to the watching Army Artillery Board that both men and missile were ready. Pershing, built by the Martin Company, will be with units in the field in early 1964. Another final chapter was written on the Atlantic Missile Range with the last research and development test of the Hound Dog. Nestled under the wing of a B-52, the air-to-ground Hound Dog drops from the mothership and streaks to its target 500 miles downrange. The Air Force Mace has been a sentinel on the outpost of freedom for years. Selected crews for this tactical weapon are brought to the Cape for system checkout and for launch training. In hardened, protected sites overseas, Mace crews are ready and waiting should their missiles ever have to come alive. This is ASSET, the first winged spacecraft and virtually a flying laboratory. ASSET, short for Aerothermodynamic Elastic Structural Systems Environmental Test, was designed to attack a full spectrum of basic research problems relating to reentry from space. Its findings will be applied to current programs and will increase options for designers working on future space hardware. In its 22-minute non-orbiting flight, it transmitted volumes of information over 137 telemetry channels. An Air Force Thor retired from overseas service with NATO sent ASSET on its successful flight. Thor, built by Douglas Aircraft Company, has launched more payloads into space than all other boosters combined. NASA uses the Thor Delta for a wide range of space projects. In May, a Delta orbited Telstar 2. Seventh in the series of Tiros weather satellites was orbited in June. In July, Syncom, a new communication satellite, was placed in a difficult synchronous orbit 23,000 miles up. This perfect operation has led to plans for placing another Syncom, boosted by a Super Thor Delta, into orbit at the intersection of the equator and international datelines. Hovering over this spot, the Hughes-built Syncom will link Asia with North America for worldwide television transmission. Radio communicators for years have been plagued by the peculiarities of the ionosphere, a globe-circling band of electrically charged particles. Scientists from the Cambridge laboratories designed a 50-pound device to take the measure of this ion band. The Air Force Blue Scout was selected to send this payload 8,000 miles into space. The Blue Scout crew assembled this off-the-shelf booster and fitted its delicate payload in place. The Blue Scout is aimed at its target in space, much like a rifle, and spin motors maintain flight stability. Project officials announced the results of the probe were excellent. But not all of the rockets reaching into the secrets of space from the Cape are giants like Titan, Atlas, and Thor. Each year, nearly 300 smaller rockets are used in scientific studies of near space. The Robin is a weather rocket used for investigation in the upper atmosphere. Air samples, high-altitude winds, and temperatures gathered by the Robin complement information from traditional meteorological research and, like the findings of the Tiros satellite, is available to all the world. This sleek-looking Nike Cajun is equipped to measure radiation. Along with high-altitude aircraft, Nike Cajun is used in a joint United States, Great Britain and Canadian radiation detection program. The Nike smoke is used in studies of wind shear. Photographs of its smoke trail reveal the strength and drift of wind currents at various layers of the atmosphere. This information is valuable in planning, guidance, and in determining the structural strength necessary for large space boosters. Yet no mechanism, however wonderfully wrought by the hands of men, can substitute for man himself. A machine can be built to stand more heat, more cold, and perhaps take up less space. But engineers cannot fashion something as dexterous as the hand, as perceptive as the eye, nor can they make a brain with curiosity, imagination, and courage. Air Force Major L. Gordon Cooper confirmed all of this in the last and longest of the Mercury flights. Suiting up, the pre-dawn ride to Pad 14, the well-wishing, the squeeze into the capsule, and the long countdown wait has become a familiar ritual. But then the count reaches its final moment. Ignition. Liftoff. And a man is riding a flaming pillar of power. The only calm man present is Major Cooper, who remarks, "What an afterburner." But Major Cooper can scarcely be counted among the present any longer. He has left the Cape and the world below, and in 5 minutes will be going more than 17,000 miles per hour. He will be in orbit. More than 700 members of the press gaze at the diminishing speck in the sky. The news is trumpeted worldwide in a matter of seconds. Europe watches Major Cooper's launch live via Telstar. Major General Leighton I. Davis, commander of the Atlantic Missile Range, directs the 18,000 people of the Department of Defense who are committed to the support of Project Mercury. In the 19th orbit of Major Cooper's 22-orbit flight, the failure of an electrical relay eliminated his autopilot and attitude indicators. Without the astronaut, the mission would have ended here in failure. Ground controls could not have retrieved the spacecraft from orbit. Major Cooper fired the retro rockets and, using the window for attitude reference, manually controlled the spacecraft during re-entry. The landing was perfect, emphasizing the fact that the most important system in space is man himself. Major Cooper elected to wait in his spacecraft for retrieval by the nearby USS Kearsarge. The band on board strikes up the Air Force song as Major Cooper emerges wearily from Faith 7 and responds with a grin and a salute. Before his flight, Major Cooper, along with other Air Force astronauts and space pilots, attended a traditional Air Force dining-in at the Officers Club at Patrick Air Force Base, Florida. Secretary of the Air Force Eugene M. Zuckert stated the need for our efforts in space.
We believe that space can be free to all for peaceful activity only if somebody keeps it free. We are that somebody.
Project Mercury scouted the frontier of space. Project Gemini will make further explorations, but much more power is needed to make the trip to the moon. NASA's Saturn, the booster for the Apollo program, will furnish this power. Standing 168 feet tall, this rocket dwarfs the people preparing it for launch. 3 previous tests of the 8-engine booster have been completely successful. Primary objective of this test was to check booster performance with 1 engine shut down in flight. This flight, too, was successful. On November the 16th, 1963, Air Force One touched down at the Cape Skid Strip, bringing President Kennedy on his 3rd visit to America's spaceport. He was welcomed by Major General Leighton I. Davis, commander of the Air Force Missile Test Center, NASA Administrator James Webb, and NASA Launch Operations Center Director Kurt Debus. The president moved out quickly on his whirlwind tour, stopping outside the Saturn blockhouse on Complex 37 for a Project Gemini briefing by Air Force astronauts Cooper and Grissom. After another briefing inside the blockhouse on Project Apollo, the president and his party, which included Florida's Senator Smathers, drove to the base of the giant Saturn. Saturn will carry an American crew to the moon in this decade, a goal established by the young president shortly after he took office in 1961. The president then boarded a nearby helicopter for an aerial tour of the space launch areas and a 30-mile flight to the USS Observation Island. The commander-in-chief was piped aboard. Donning a sailor's jacket, he looked every inch the naval officer he was during World War II. The fleet performed flawlessly, and President Kennedy saw his first Cape missile launch, a Polaris, from the submerged nuclear submarine, the Andrew Jackson. A proud commander congratulated a proud crew. The president returned to the Cape by helicopter. His visit expressed his continuing support for the nation's space program. President Kennedy bids his farewells. On November 25th, the Cape was closed. Officers and men of the Air Force Missile Test Center assembled for memorial services. Brigadier General Harry J. Sands, Jr., the center vice commander, spoke.
He moved among us with warmth and interest and awareness of our efforts. It is well to remember that we are assembled here today not because of the shocking way that he died, but because of and in tribute to the way he lived. We salute the memory of our late president, John F. Kennedy, and salute as well, in token of our steadfast steadfast devotion to duty, the new President and Commander-in-Chief, Lyndon B. Johnson.
Demonstrating a determination to move forward toward the goals established under the late president, Cape workers the next night launched an interplanetary monitoring platform. It was the 21st straight success for the Thor Delta. NASA underlined this determination the next day, successfully launching the Atlas Centaur. The entire Centaur upper stage was placed in orbit. On Thanksgiving Day, President Lyndon Johnson announced the Cape would trade one world-famous name for another. Cape Canaveral will hereinafter be known as Cape Kennedy.